We are Section 10, Group 4. We were the Engineering Recycled Concrete group. I'm Nathan Gunlock.
I'm Jack Diederich.
I'm John Thiesing.
And I'm Matthew Harris. First, we are going to start off with the needs assessment and problem formulation. Our design statement was to develop a MATLAB model for the effect of recycled materials on the stiffness and strength of concrete based on previous research done at Notre Dame, determine the acceptable strength and stiffness loss values, create samples of concrete based on these values, and test these samples in the materials lab on their stiffness and strength. This research was previously done by Dr. Karama, and the process of making concrete is an expensive process, and it is non-renewable, so we're looking into seeing whether using recycled concrete from old buildings and structures is feasible in new structures, and will it have the appropriate strength and stiffness to hold up. And this is an image of us testing one of our concrete cylinders in the materials lab in Cushing Hall.
Now for the abstraction and synthesis. Here are the model equations we used in our GUI dealing with relative strength and relative stiffness of our recycled mix compared to a normal concrete mix. They are linearly dependent on the ratio of A to Na, which is the ratio of absorption of our mix to natural mix, which is just the amount of water that concrete takes in when it's soaked. It's also dependent on D, which is the deleterious material content of the recycled aggregate, which we're assuming to be 0 for this project. And then for relative strength, it's also dependent on the percent replacement, or R, of our recycled compared to our natural aggregate. And equation 3 at the bottom shows how to calculate the exact absorption for a mix, which also uses R, SG, which is just the specific gravity dealing with the weight of the natural aggregate and recycled aggregate, and the individual A values of Na and RCA.
So now for analysis, this is where we get into the GUI that we made. So the goal that we said for our GUI was to find an R value that satisfies the strength and stiffness loss limits. So our first solution was to have the user vary the R value until the predicted strength and stiffness losses would barely lie within the acceptable range. So this is our first GUI here, rtool.m. And basically, say you're trying for 75% strength and stiffness loss, so you want to get it above that. You basically vary this until it gets pretty close, and we found that that was actually at 0.77, which is the value that we ended up using. However, this is a rather tedious process, so our second GUI used nested while loops to do this approximation for us, as shown here. And here you simply just have to type in that you want it to be above 75% for both of them, and that you want the precision to be within a percentage. And then here you go, you have the same values as the last one that have been exported. And so to implement this, we crushed the concrete in the materials lab. And there it goes right there.
And in order to analyze the data that we received, we plotted stress versus strain for each cylinder, and taking the best fit of that line, we could determine the slope was the stiffness. So here we see a table of the peak stress value and the elastic modulus, which is the stiffness, for each concrete sample, and we averaged the RCA divided by the average of the Na to yield experimental results of stiffness, relative stiffness being 74.28% and relative strength being 73.45%. The relative stiffness, the experimental changed by 1%, and for the strength, it changed by about 20% from the predicted GUI values.
And that was our engineering recycled concrete project. The idea is that someone could go and look back at this, and for a different type of concrete that had different absorption, deleterious material content values, and specific gravity values, they could go back and they could use our model to do a similar analysis on it to figure out how much recycled aggregate of that concrete they would be able to put in to stay within specific strength and stiffness loss limits.